just the positive 53i. Let's take a look at problem A. In problem A, in this next section, we've got a fancy fraction that looks like -9 plus the square root of -18 all over 3. So we'd start out with the same way we've done every problem in this section by starting out with the negative underneath the square root. Let's simplify that first. So we've got our -9 and our 3 on the bottom. Be careful, you cannot reduce the -9 and the 3 unless you can factor something out of the entire numerator. And right now we can't. All we can do is start by pulling out the I from inside the square root. So let's start by pulling out that I. And then the question is, can you break down the 18 into something you can take the square root of? Well, I can break down the 18 into 9 times 2. And then that way I can take the square root of the 9, which is 3. However, I cannot take the square root of the 2, so that's going to stay inside of the square root. Now the question is, why would you want to do this? It actually makes your life a little bit better because now what you'll notice is on top I have a -9 and a 3. So both terms on top are divisible by a 3. So that means I can factor out a common factor of 3 from everything on top. That's what's going to help me reduce or simplify this. So factoring out the 3 from the -9 will leave me with a -3 plus, well, 3 will go into 3 one time, so I'll have I square roots of 1i square roots of 2. Now, just like before in other math classes, if you have a 1 in front of an I or an X or anything, remember you don't have to write that, so we can hide that. So I can rewrite this as 3 times -3 plus just a regular I square roots of 2 over 3. Now here's where we want to focus. Have a 3 on the top and the bottom. Those are both divisible by 3, so we can go ahead and reduce that. That will turn those both into 1s. However, now remember, if you have a 1 on the denominator of a fraction, you don't need to write it. You can just kind of hide it. And then that leaves us with just a 1 out in front of something with parentheses. Multiplying something by 1 won't change it, so we don't need to write that either. So what that leaves us with is just what was in the parentheses then. Our final answer is just going to be that piece, which is a -3 plus I square roots of 2. Now I do want to point out that what was underneath the square root, the 2, didn't get affected by anything because it was safe underneath the square root. So we can re-hide the 1 on top and the 1 on the bottom because they're not necessary. And then our final answer is just what's in the parentheses, the -3 plus I square roots of 2. And so our final answer is -3 plus I square roots of 2. And again, notice that what was in the square root did not get affected. It's kind of safe inside of the square root. It does not get affected. We can't kind of break through that barrier of the square root. Now let's try another one. Let's take a look at problem B. In problem B, we have 20 minus the square root of -8 over 2. So once again, we have a negative inside of a square root. So I would start there, because you can't reduce anything on top anyways unless you can factor something out, and right now you can't. So let's leave our 20 and our 2 on the bottom, minus, now let's pull out our I, because of the negative inside of the square root, and let's see if we can break down our 8 into 2 factors, one of which we can take the square root of. And 8 can get broken down into 4 times 2. So we can take the square root of 4. It will come out as a 2. However, we still have an extra factor of 2 that will be stuck inside of a square root. Now remember, the goal of this is we want to reduce, which means we want to factor something out of the top to see if we can reduce it. We do have a 20 on the top and a 2. So the common factor that we can pull out of everything on the top is a 2. Notice again that we are not crossing the barrier of the square root. We're only pulling out common factors that are outside of roots. So let's see what happens when we pull out the common factor of 2. So pulling out the 2 from the 20, well, 2 goes into 20 10 times. Minus pulling out the 2 means that that 2 would pull out and turn into a 1. Now we would still have our I and our square root of 2. Notice again the square root of 2 is not affected in any way whatsoever because it's safe inside of the square root. We have a 2 on the denominator. This will stay there for right now until we actually go into reducing. So now what has happened due to factoring is we have a factor of 2 on top and a factor of 2 on the bottom. So we can reduce those by dividing both the top and the bottom by a factor of 2. That means the 2 will get divided into both 2's, which will turn both of those into 1's. And just like the previous problems, remember when we have a 1 that's by itself on the denominator, we do not need to write that. And also when we have a 1 on the numerator out in front of something that's being multiplied by something, we don't need to write that either. So what that will just leave us with is what's inside of our parentheses here. The 10 minus 1i square roots of 2. And we've said this before as well, the 1 that's out in front of the I does not need to be written either. It's like saying 1x. You don't need to write the 1 out in front of x's either. So we can re-hide that and rewrite that as 10 minus I square roots of 2. And we're done. Let's take a look at C. In C we have 2 plus the square root of negative 20 over 8. So what we can do is again start the same way. We do have a negative underneath the square root. Let's pull out the I that it's going to turn into. So we've got 2 plus, we'll pull out the I from the negative underneath the square root, all over 8. Now let's talk about the 20 that's also underneath that square root. Can we break down the 20 into 2 factors, one of which you can take the square root of? And the answer is yes, it can be 4 times 5. So the square root of 4 will come out as a 2. However, you cannot take the square root of 5, so it will stay inside of our root. So that's a good start. Now what we should notice is that we have a 2 and another 2, which means I can pull out a greatest common factor of 2 out of everything on the top. So the question is, if I pull out a 2 from both factors on top, what will that leave me with? Well, be careful. Dividing the 2 into the 2 doesn't mean that it disappears. There's still a hidden 1 because 2 goes into 2 once. Plus, we also end up with a 1 when we divide 2 into 2 here, but we end up with 1i square roots of 5. Now, because the 1 is not by itself and it's in front of an I term or a square root term, we don't actually need to write the 1, so we can re-hide that if we would like. So we've got 2 times on top 1 plus I square roots of 5 all over 8. So now we can reduce our common factors. We've got a 2 and an 8. Those are both divisible by 2. So I'm going to divide the top out by a 2 and the bottom by a 2. So what this will do is dividing both by 2 will give us a 1 on top and a 4 on the bottom. So that gives us 1 times 1 plus I square roots of 5 all over 4. The one thing that, again, we do not have to write is the 1 that's out in front, because multiplying anything by 1 means it won't actually get changed by that 1, so I don't need to write it. So on top, I end up with just my 1 plus I square roots of 5 all over 4. And there's nothing you can do with this. That's as nice and neat as it can get. So that's our final answer. In the next group of problems, we're actually